If you don't know who I am, I'm just a member of the London Centre. I'm the observers group chair. I try and look after our observatory. And what I do every month is I just do this talk that's sort of very random, and it's just all the stuff that I encountered during the month that I want to share with everybody. And it's usually observing oriented, and I try and talk about what's up in the sky. And I'm just looking, were you guys using the remote? Was it working?
Yeah.
Oh, it is working. Okay, good.
Just check.
Right, so there's our title slide, so I'll just go from there.
Is the green light on?
Didn't work.
Yeah.
Did it turn it off?
What do you?
Give it a push, see if it works.
Okay, green light.
Yeah, push that, I get it. Okay, let me turn it off and on again, and we'll just. Oh, it is off. Wait a minute. Where's the dongle on this side?
Right there, yeah.
Okay, let me push it on. Let's see if it'll talk, and then we'll try it.
Presentation.
Does the arrow work? Yeah.
Sorry?
Does the down arrow work?
The down arrow. I don't see a down arrow. Well, I'm gonna try that. Yeah, I was just looking for that.
Oh, no.
Do we have arrows on this
No.
board?
Now try.
Try it now. No. Oh wait, no. What did you do? You just use the arrows. Page up and page down. Okay, well, just do that. That's more than adequate. That thing doesn't really matter. It could be the battery's getting weak too. Do we ever change that? I don't know.
I'll look at them. I do have balance.
Yeah, it doesn't matter. I don't need it. I can do the buttons. Maybe it does work. Yeah. All right. So yeah. So this is just. I don't have an observatory. This is a great place in the driveway because there's a garage on one side, a house on one side, and a bunch of bushes on the other side. So it's actually kind of dark there. And this is a telescope I grabbed off Astro by Cell. It's an 81 millimeter Williams Optics Zenith star. And I was using that just with a Manfrotto head for a while because I wasn't sure what I was going to do to mount this thing properly. And so eventually I decided what I would acquire is one of those Spaboni SV225 all-TAS heads because they're really cheap. They seem to be really popular. They're not perfect if you watch some of the reviews, but it seemed like a good way to go. Here's a picture of one of those things. It's on top of a Manfrotto 75. So it's nice because it's slow motions. It's got lock knobs. It's got like a handle for back here for moving it around because you don't want to grab the telescope and move the telescope. You're just going to be messing with the dovetail if you do that. Seems to hold it really well. I like it. It's very high powers for following the planets with the slow motions. So far so good. And what I did when I assembled, when it comes, and so there's this hexagonal piece here. This hexagonal piece fits in there, but there's a bit of slop. And Ed Ting talked about using plastic shims to tighten his up. This guy here, I found a video when he uses 0.4 millimeter aluminum, and he's made a shim to go right around. So I just thought when I assemble mine, I'll just shim it. So far so good. The aluminum is a great idea. You could do that later. These are really cheap. Like they're on Amazon for 190 bucks, and one was on sale. They put them on sale 2 weeks ago for 170 bucks. So I bought one. You can't go wrong. You can't buy the Porta 2 anymore, which is the really famous all-TAS mount for small telescopes. And so we'll see how it goes. So I'm going to share a few things that are observing related with you. I found this on Cloudy Nights the other day. I want to read this to you. It sort of ties into my overall theme of small telescopes and observing. But somebody writes, a few years ago, I was surprised at how sharp the image was through my 4-inch f15 refractor. And I did a long series of comparisons among my scopes to see if this was real or an illusion. It was real. The unobstructed optics and forgiving f15 focal ratio does indeed give an amazingly sharp image. Last year, I bought a new 6-inch f8 Dobsonian as an example of a beginner scope, and comparing it with my 3-inch f16 and 4-inch f15 refractors showed the refractors do indeed give a sharper, clearer image, while the 6-inch f8 Newtonian gives a brighter image. Brighter image may even contribute to the apparent reduction in sharpness as it makes little flaws and foibles in the image easier to see. However, close examination of closed double stars shows that the refractors give sharp airy discs with a single tight sharp diffraction ring. The airy discs and the diffraction rings in the Newtonian were spiky and less defined. And I thought how true that was. I mean, just in the last month, comparing an 81 millimeter refractor to my 6-inch f5, this is absolutely true. I get these sharp little, I get these sharp buried discs with single diffraction rings in this thing. Great for double stars. The 6-inch f5 has a 33% central obstruction. It's got a bit of astigmatism. And, you know, you need 200 power to split epsilon Lyra in that thing, and you shouldn't need that at all. But it's truly a Ridgefield telescope. It's not sort of a high-powered planetary or, I would say, double star telescope at all. It is okay for looking to say at the planets. If you throw the Bader contrast booster on it, it does improve the contrast quite a bit. So they can be a good planetary telescope. Though if you wanted to do planets, you probably want to keep up around f6. So that, I thought that was an interesting aside, and this ties in, if you remember Terry Dickinson's famous article about, you know, Terry and refractor land. He talks about his very first telescope, a 3-inch f16 Unitron, which he loved, and he pondered, why can't I get those sharp views in bigger telescopes? And then when astrophysics started bringing out the apochromatic refractors, he became an addict and started buying all those because he likes that very sharply defined view that really only a refractor can deliver. Now, Chris just mentioned in his talk that APM 7-inch f6, which sounds like an achromat. And it sounds like he's getting really great results with that. Some of you may know that APM a couple of years ago brought out a 6-inch f6 with FPL 51 glass in it. That telescope wouldn't give you quite as much aperture as Chris's telescope, but that telescope with the FLP 51 would really reduce the chromatic aberration to a level that wouldn't really matter at all. So if you aspire for something like what he's done, the telescope that would do that is available. So just moving along, I wanted to show you this was something else I found on cloudy nights, and I wanted to just relate that to this new telescope. So here's a sketch somebody did with an 8-inch f8 reflector at 160 power. And this is their view of Jupiter, and it's a nice view of Jupiter. And I'm sure actually that an 8-inch, a good one, would show more detail than that on Jupiter. But sketching, you're always limited by your ability to sketch. But I will tell you, in this like little 81 millimeter, that's basically a 3-inch f7 refractor, I can see all that on Jupiter where the seeing is perfect. And I also think I'm getting more nights with perfect seeing with only the 3-inch telescope. But like the first night out, I saw 5 bands, great red spot, the colors, tiny, but it's all there. It's because it's just perfect. So I'm just going to continue on this theme of why you guys should all have a grab and go type telescope. One of the things I wanted to do, here's another aside based on my surfing the web. I have a 40-year-old 2-inch diagonal. I thought maybe it's time to upgrade that because it's kind of light duty if you're putting really heavy eyepieces in it, which I've acquired. And I was astounded at the price of the top of the line diagonals, like $630 for a 2-inch Teleview. This is their Everbright dielectric, not their enhanced aluminum. That was a little bit cheaper, but $630 plus tax and shipping. Can you imagine? So I started looking around, and then Astronomy Plus has a 99% one for $120, which seemed a lot more reasonable. Why I wanted one, actually, my main reason is I'm putting heavy, expensive eyepieces in the back of a refractor. So that means if that ever falls out, you've got a problem. And I wanted something with, I don't like undercuts on eyepieces for visual observing, but I do believe you should have undercuts if you're using a Schmidt-Cassegrain screen or a refractor, because you never want that diagonal to come out if it gets loose, if it's got something really heavy in there. So in the end, I rooted around and I found a used me 2-inch dielectric for $70. That was more my speed. So you have to just keep your eye on cloudy nights. And then if you look at this slide for a second, now I have never heard of I guess it's the ES show, but if you look at the personalities along the bottom there, you might recognize somebody. And so just the other day, Caitlin was on there, and it was really interesting, Caitlin's comments, because I guess you didn't know the questions in advance. And the guy just starts firing these questions at you. It's like random questions from around the web. And you handled it very well. You just came right back with the guy and you gave him all the scientific stuff that he needed to hear. So good for you. That was nicely done. And then continuing on with random things. I saw this on Instagram, so I thought I'd show this to you. The red line shows how far the Voyager 1 spacecraft will travel in 1 million years. So here's the sun right here, and this little red bar is how far the Voyager spacecraft will travel relative to our galaxy, which is about 120,000 light years across, in 1 million years. Okay, so I did come across this website. I knew about these guys and I'd seen their website before, but I show it to you because I think we should all look at that website. I think they're doing a really nice job. And I think it's worth everybody taking a look at the North Shore Area Amateur Astronomers website because maybe there's some things there we could do with our website. So I just throw that at everybody. Astro by Cell, I like to talk about this every month because I guess I'm an inveterate Astro by Cell watcher, and that's where that 81 millimeter Zenithstar came from for not much money, I have to say. Now, I know you're all saving up for one of these, but I also know that by the time you get up to the requisite $41,180, that it could be out of stock by the time you're ready to buy it. And so I want to encourage you again, like to be thinking about small grab and go telescopes, of which this is not. And so some deals in the last month. Wow, somebody had a Teleview Pronto with the 2-inch focuser, with a Teleview 2-inch diagonal. I just showed you how much one of those is worth. And the guy's selling it for $675. It's a little bit much, but the quality on those things is really high, and you can just plop that on a very light tripod and run outside and do some observing. So there's one deal. This was a great deal. I think it's still up there. Some wondered you should buy it. It's a very old Celestron 100 F9 ED scope. So it's got the extra little dispersion glass in it. This is like the Skywatcher 100 F9s. It's the same optics. Very highly regarded. $400 for a 4-inch refractor. That's a good deal. I mean, you have to mount it. And actually that Spivoni SB 225 would probably hold it, although I don't think very well. You need something a little better than that. But I just throw that at you. This one is a must buy. This is, some of you who are interested in the plans will realize that there's a few manufacturers carrying a 102 F11, which had the FPL 51 glass for a long time. And then a few years ago, they upgraded it to the FPL 53 glass, which is the best glass for reducing chromatic aberration in the refractor. Not only did they put the good glass in it, they made it F11. And so here's somebody in Canada actually selling one of these for $1,000. That is very nice telescope if you're into double stars and planets. That's what it looks like compared to like a little short refractor. So again, you need a substantial mount for that, but wow, I've never seen one of those before on Astro by Cell. Oh, I was going to read an Ed Ting. While you imagine your 200 millimeter refractor that you're saving up for, I will just read you a little quote to emphasize the continuing point I always make about why you should get something that's easy to use. And I have it right here. And many of you are familiar with this, but Ed Ting is the telescope review website. If you've never heard of the guy, who's got a website where he reviewed telescopes for years, and then he decided to open a YouTube channel and he reviews telescopes there. And he's got a buying guide for beginners on his website, and I will just read you what he says, and you see what you think about this. So he says, audiophiles have a saying that goes something like this: the stereo system which reveals the most music to you is the one that you use the most. For most of us, that's our car stereo. Astronomy is a lot like that. It says the probability that a telescope will be used is inversely proportional to its size. This seems to apply to just about everyone, regardless of experience. I've carried on a correspondence with a fellow astronomer. He has an 18-inch Luxo Dot. I have, and I just mentioned this to you, you can get one for $675. I have a tiny Teleview Ranger. Our conversations tend to go something like this. Me. So, did you see Saturn last night? Him. No, it was too cold to go out observing. Me. Oh. Him. But my 18-inch Dot blows away your puny 2.7-inch refractor. Blows it out of the water, you tiny dweeb. And Ting says, okay, so maybe it doesn't go exactly like that, but you get the idea. Sure, he's got me whipped in aperture, but I got in 2.7 inches of observing last night, and he got in 0. Little telescopes get used more often and thus show you more. So, very good point by Ed. And that's why I keep hammering this, because we want to just get out there and do this. We want to observe, right? We want to see things in the sky. So this month I cobbled it all from the latest astronomy magazine. Sometimes it's Sky and Telescope, which is one of the 2 big astronomy magazines. If you're new to astronomy and you're wondering which one to buy, I'd say either one is pretty good. Just pick up whichever one you can actually get your hands on. So that's an interesting issue. It talks about search for extraterrestrial life. Here's one of the diagrams from this month's issue. And so what we've got here if you take a look at it, we've got like the blue here sort of represents the fact that this is where the sun is, and there's the sun right there. And what it shows is that Orion is getting pretty close to the western horizon. Orion is starting to disappear, and this is for the date May 18th. Okay, so it's just shooting ahead a little bit. And some of you may have noticed this, but there's Venus right there. In the last couple of weeks, I've noticed Venus low in the western sky. So if you've seen that super bright star in the western sky, that's what you're looking for. And it's heading up into Gemini towards Jupiter. And there's Leo, which Tyrone talked about, and I want to talk a little bit about Leo as well tonight. And there we go. So on May the 19th, 1 hour after sunset, we're going to have Venus here above the western horizon, and the crescent moon is going to be in between Jupiter and Venus. So that's something to look forward to seeing. That would probably make a nice photograph. And then the other thing that's happening this month coming up, here's the diagram from Astronomy Magazine. Like there's a bunch of double shadow transits on Jupiter. So this is also something that's worth running out to see. And this is again why you want to just run outside with your 3 or 4 inch refractor. You don't necessarily want to part on your 8-inch refractor or something like that. But on the 6th, there's a Callisto transit with simultaneous Europa and Io occultations. On the 7th, an Io transit with a shadow transit. On the 15th and 16th, Europa and Ganymede shadow transits. And again on the 22nd, Europa and Ganymede shadow transits. So this is all something that's worth getting out to take a look at. And this nice one is the May 15th one. And I showed you this last one because I'm talking about shadow transits, and because Jupiter is really well placed in the western sky right now, like you can go out right after dinner. This app here has been working fairly well for me, and you can just turn it on anytime, and you can see what's going on with the moons and where they are, and you can put in the motion too. Okay, so Tyrone had talked about, earlier. Oh, you mentioned Cancer, not being able to see Cancer. From London skies, because London's too bright now. Like it used to be, you could look up and see the constellations. It's hard to find them now. So if you're trying to learn the constellations, say with the constellation chart in the center of Sky Telescope or in Astronomy Magazine, you probably need a pair of binoculars now for the stuff that's not really bright, which is sad but true. I had thought with this new refractor, I'd like to look at the Beehive cluster M44. And so I was looking and looking and looking from my little driveway observing spot that I showed you. I couldn't see Cancer either. Like it's gone. Like the stars are faint and the sky is too bright. And so then I thought, okay, so I popped a 2-inch eyepiece into that little refractor, and that gives me a 4.4 degree field of view. And I knew where to point the telescope, and I just pointed the telescope, and there was the beehive, nicely framed by that really wide field of view. And I thought, well, while I'm at it, I want to try and see M67, and I star hopped down to M67, that one is very difficult to see in the city. Like you could see like a smattering of stars. You could tell it was M67, but probably if you hadn't seen it before, you wouldn't know. But little telescopes are the best telescopes for giving views of very large clusters and things like the California Nebula. And then the thing I wanted to also mention to you, and I did mention this in the forums when I wrote this up, but as I was coming down here, I noticed there was a carbon star here, X Cancri. And so I swept over and took a look at that, and oh my God, that is just amazing. That is apparently one of the brightest carbon stars in the night sky. It ranges in magnitude. I think I have a close-up chart here. Yeah, it ranges in magnitude from, oh, there it is right there, about 5.5 to about 7.5. It must be bright because I looked through it at 19 power, and like I saw these stars, this little triangle of stars around it. I said those 3, and this like reddy orange star right in the middle, just as bright as those other 3 stars. I thought it was beautiful, and that was from the middle of London with all this light pollution. The refractor with the 2-inch eyepiece encompasses this star and this star, so the refractor's view is this wide. So it's pretty easy to sweep around and look for things. And then, so here's a sketch somebody did. There's a guy in Maryland, Richard Bohr, and so he observes with a 6-inch refractor. And here's his view of X Cancri right here. At a little, well, twice the power at least that I was using, twice or half the field of view, I should say. But that's the kind of thing you can see even from downtown London, really. If you've got a small refractor, like some of this stuff, if you get out and try and find it, sometimes you'll be surprised what you can actually see. So coming up in the night sky, some things. We've got Comet 10P Temple is supposed to be pretty good in May. It's not going to be a really bright comet, but I'll show you what I like about it. It's going to be about magnitude 9. So you're going to need at least a 3-inch refractor to see that. maybe a 6-inch, might be a 6-inch Newtonian might be better. So apparently this is like, since this thing was discovered in 1873, this is like its top 3 apparition. It's really well placed, it's relatively bright, and where it's supposed to be, I'll just show you where we're going to look. Here's M11 right here, the wild duck cluster in Scutum. And I want you to take a look at this planetary nebula right here, 6751. Those of you who are familiar with this part of the sky realize it's like right in the middle of the summer Milky Way. Well, let's go to the next one and look for 6751. There it is right there, right up here in the right-hand corner. So the whole month of May, Comet Temple 2 is just going to be right in the middle of the Milky Way and reasonably easy to see. So it's a great photographic opportunity, and it's also a great opportunity to see this thing. You've got a month to look. Oh, and comet. So if you want more detail on these comets, right, there's the Skyhound, the comet chasing website, gives you all the latest things and downloadable charts. That's useful. And then also, I just mentioned the Comet Observation Database is another place you can go. I'm just thinking about websites that people who are new to astronomy might not be aware of. I came across this guy recently. I think I'd seen him before, but this Van Buchanan guy is obsessed with comets, and he just gets out there and photographs them all. So that's kind of a nice resource too. Because in astronomy there'll be somebody who's really into something for a while, but then life takes over and they drop off. But right now he's very active with this, so it's a good website. And then we have an upcoming asteroid as well. So there's a neat asteroid you can get out and see. So let's go. Oh, here it is. So Egeria in May is going to be doing a little arc right by this star here, 80 Virgo. Okay, and this is a review. So let's take a look at that in a little bit more detail. I think I have another slide. And I wanted to track down 80 and I couldn't really find it. But what Astronomy Magazine was saying, and this is cool, Peter Judkey and I have done this with fast moving asteroids before, is get out and watch them move, like actually watch the motion in the solar system. So here's Spiker right here, and then we come up to 74 here. 80 is unlabeled on the Pocket Stylus, but I found it, so that's 80 right there. So this thing was discovered in 1850 by this guy called Annabelle Gasparis. It's about a magnitude 10 asteroid. It's only 125 miles in diameter. So what Astronomy Magazine is suggesting is, I'll go back one. They're suggesting get out there when it's near a star, such as 80, or one of these other stars that's on this chart, and just spend a couple hours and just watch the thing move against the background of stars. It's kind of a neat thing to do because as amateur astronomers, we don't often see that kind of motion in the solar system. Okay, so let's go forward. Oh, and you'll recall last month I talked to you about double stars, and I showed you this picture. This is like a whole bunch of RASC types about 120 years ago with their 3-inch refractors. And of course, what did they look at with 3-inch refractors? Well, double stars, planets, and the moon. So these are some of the things that you can do in the city with a small telescope. If you get yourself like a little Pronto or an 80mm refractor, there's a lot you can do. And I wanted to introduce another idea. So last month was double stars. This month is going to be variable stars. So let me just talk about variable stars briefly. And I wanted to highlight this book here, David Levy, who's visited our meetings many times. This is the second edition of his book, The Guide to Variable Stars. So I'll just give you a little summary of what's in that. And I want to focus in on one of those stars. So, the book starts off and he introduces like the basic categories of variable stars. And then I mentioned last month this book here that was published in 1909. And this was the one by William Tyler Alcott, who you'll recall, with a few other people, co-founded the American Association of Variable Star Observers in 1911. Okay, well, that's interesting. So we go ahead, and here's the AVSO's website. And of course, they've got this banner, Discover the AVSO. It's been around for a long time. Very few amateurs observe variable stars. But I thought I would talk to you about that a little bit, because this is also something you can probably do in the city. And I've been doing a lot of that. Turns out astronomers need your help. Variable stars are stars that change in brightness over time. There are too many for professional astronomers to monitor alone, so we need your help to monitor these stars over days, weeks, and years. Okay, so it turns out on their website, there's actually a 10-star training tutorial, and the 10-star training tutorials are designed for novices who have no prior experience observing variable stars. So they teach you how to do that, and David Levy's book also goes into great depth on how you estimate the brightness of a variable star. So there's a couple of sources there that I've just highlighted. Now, the neat thing that the AAVSO has, if you have a particular star in mind, and you don't even have to be a member to access this, they have the variable star plotter. And so you can plot a quick chart for something you might be interested in going out and taking a look at. And typically what you do is put in the name or designation of the object. And then the other thing you would do is you would choose your chart orientation. Like, so if you choose something visual, it's like a binocular style chart. And if you're using a Newtonian, you just turn it upside down. What I like with this little refractor I just got is I can print a mirror reverse chart. So I can print a chart that corresponds with the view in this refractor or Schmidt-Cassegrain. And then the other thing you do is you choose your chart scale. So the star we're interested in is this R Leonis, and I'll talk about that one in a minute. But the scale, you pick an A, B, B style chart for looking at stars visually or binoculars, and then you go into the weeds for stars that are quite faint, and those stars have a much larger scale, and they give you the fainter stars that you need. And let me give you an example of that. Oh, but I'll also mention this. They have a star is easy to observe list. All are great stars for beginning observers. So throughout the year, they list all the ones they think are the best ones, and they go down the list. There's R Leonis there, varies from about magnitude 4.4 to magnitude 11.3. And R Leonis have a page on it. It's kind of a famous star, and I'll talk about that. And it was discovered back by a doctor in Danzig in 1782. It was the 5th variable star ever discovered, the 5th one. And one of the reasons it's well known in modern times is because of this guy, Leslie C. Peltier, who lived from 1900 to 1980, who was a very prolific comet discoverer and a very serious variable star observer. And we see the light curve for this star over about 10 years and the range of magnitude. And so it's a fairly regular star, but it changes in brightness. And I wanted to, okay, so Peltier, Leslie Peltier, was 18 years old when his first encounter with variable stars occurred. Only recently had he paid for his first telescope, a 2-inch brass refractor, with earnings he'd saved from picking strawberries. Like many new observers, Peltier, and this is kind of me relating what observing's like to you, he felt frustration of not being able to find the variable star plotted on the star charts he'd obtained from the AAVSO. He wrote away as an 18-year-old, he wrote away to the AAVSO, and William Tyler Olcott, they sent us to get him started. However, on March 1st, 1918, after many nights of unsuccessful attempts at variable star observing, our Leo revealed itself to the enthusiastic young man. And he goes, to my great delight, about a minute later, and just a little more than 1 field to the northeast of Omicron Leo, I found a tiny triangle of stars with R, my first variable, forming one angle precisely as shown on my chart. And so what I was going to do next, I wanted to read to you a little excerpt from that book. Some of you would have read this book. Others who are new to astronomy probably have never heard of this book. It's called Starlight Nights, The Adventures of a Stargazer. And so he did an autobiography of being an amateur astronomer. It's out of print now, but you can find used ones. Like, this is just gold. If you're into visual astronomy, this is a great book to read. And Chris tonight was talking about William Sheehan's biography of Edward Emerson Barnard. I would recommend that as a fabulous book for people who are interested in observing as well. And so let me just read to you a little bit about this night where Leslie Peltier looks for this R Leo star. And he says, as soon as my star atlas arrived, I got out my charts and working very carefully, I made a tiny dotted circle on the maps to the precise location of each one of my variables. It was now late February and the skies for seemingly endless nights were completely cloudy. Finally came a change of weather, and with it a clear, cold night. As soon as darkness fell, I bundled up with telescope, atlas, and charts in my mittened hands. I went out to find my variables. 2 hours later, when I returned, half frozen to the fire, I had not found a single one. Nor was I any more successful on several succeeding nights, and I was becoming more and more discouraged. Finally, however, on the night of March 1st, 1918, I set my telescope up near the northeast corner of the house to keep out of the wind. That reminds me of what I'm doing in my driveway. and got out my chart of the variable R Leonis. I pointed the telescope at the fourth magnitude star, Omicron Leonis, and using it as a base of operations, I started exploring the adjacent territory. To my great delight, about a minute later, and just a little bit more than one field to the northeast of Omicron, I found the tiny triangle of stars with R, my first variable, forming one angle precisely as shown on the chart. Oh, well, I'll just add a bit to that. Why had it has no success? Why had success been so long in coming? Simply because I had no mental image of what to look for. I had not bothered to figure out just how much of the chart area was covered by the instrument's field of view. So that's instructive. That's instructive. Okay, let's keep going. So, did I just? Yeah, I did. Oh, okay, I read that and I wanted to go to this. So I want to show you where R was. So if you take a look at this chart from the Pocket Sky Atlas, Tyrone talked about Regulus and this backward sickle of Leo the Lion. And here, actually, here's Cancer right adjacent here with M44, the Beehive cluster, and M67, and there's R right there. So R is actually a pretty easy star to find because it's near a really bright star that you can actually see in light polluted London. So that's important. And so let's just zoom in a little bit. So what I did is I went to that variable star plotter, and I put in the reverse chart with Regulus on it and R Leonis. So that's why it's flipped relative to the chart that I just showed you. Because this star gets reasonably bright, like magnitude 4.4, this is like a binocular chart, and you see a 3.5 star, 5.4 star, 4.4 star, etc. So you use your binoculars to find and estimate this star when it's bright, but it goes down to about magnitude 11. So when it gets really faint, none of these bright stars really help you, and you need another chart. So here I've plotted a chart that's more detailed. That little triangle that Leslie Pelche mentioned is right there, and there's R Leonis. So when you're zoomed in like this, now you're seeing 11.5, 11, 10.5, 11.3. Now you've got some stars you can estimate the brightness of R with, because these are fainter stars that are on that level. Okay, so, oh, hang on. I think I screwed up. Sorry, I got ahead of myself. Did I not? Wait a minute. I think I did. Oh yeah, see, look what I was supposed to do. I was supposed to read page 68 to you. So I brought along David Levy's Guide to the Stars. And so I've read to you Leslie Pelche's first encounter with R Leonis. I wanted to read to you David Levy's first encounter with R Leonis. There's a whole history of amateur astronomers looking at these things. And here's what David found when he started to do this. On a bitter January night in frosty Montreal, I first watched R Leonis. A cold front had just passed through, sound familiar? Leaving a crisp, starry sky. Checking my variable star chart, I began to look for R. It was frightfully cold. After an uncomfortable 45-minute search, I finally found R Leonis as it rose through the haze and smog that hugged the eastern horizon. By this time, I was so cold that even the simplest and smallest motions of the telescope were magnified into an agonizing exercise that taxed my whole being. I'd finally found a faint magnitude 9.3 star graced by two other stars, chambermaids assisting a stellar queen at 9.1 and 9.6. It was so cold that the telescope tube froze to its mount, and I couldn't even take the poor instrument inside. Quickly, observer minus telescope moved inside for some warmth. Never had hot chocolate tasted so good. Still outside, hundreds of light years away, shone my new variable. On that frigid night, R Leonis taught me two important lessons. One was that the variable star observing can be challenging and worthwhile. The other is that to observe variables properly, one must first acquire a feeling for them, a genuine concern for what they were doing, and a will to undergo some discomfort to remain in touch with them. You may not feel this the first cold night out, but you will as you get more familiar with a variable star's behavior. Okay, so let's continue. I didn't mean to jump over that. So there it was, and there's our charts, and this is this triangle that everybody's talking about right here. And then, okay, I decided, I should try and follow in the footsteps. When I bought my first telescope, I had to replace the diagonal. I got a very large diagonal because of that. Someday I'm going to observe variable stars, and I want to have like a telescope with a secondary mirror that's big enough that the field is fully illuminated so that I can make accurate estimates. Well, I never did that, but this is something I decided to give it a go. So this will sound familiar when you compare it to what these other guys discovered, right? By this time it was about 9:30 and cold. So before I hunted down our Leonis, I headed inside for some fleece mittens to pull over my cloths. Not long after, I realized I was confused by the wide field chart I printed. I couldn't remember if the bright star was Regulus, and this necessitated yet another trip back into the house to gather up my Padre Skylis and, for good measure, the northern edition of Uranometria. And then naturally, as soon as I returned to the scope, I suddenly recognized the star patterns adjacent to Regulus and headed up towards our Leonis, star hopping my way at 17 power. At low power, I couldn't see the little triangle of stars encompassing R and dropped in the 9mm Nagler for a closer look. The little triangle, of which R is one corner, was immediately visible, and a close examination revealed it was a red star, as expected. The standard advice when estimating red stars is to take quick glances, as staring at them tends to make them appear brighter than they are. So I thought that was kind of interesting to follow in the footsteps of the great observers and see what they saw. And so I have made two estimates of our Leonis. On March 23rd, I called it 8.8, and on April the 11th, I called it magnitude 10. Had I had more time this week, I would have printed off charts for everybody and encouraged you to all go out there and make an estimate. And I think what I will do next month is give you a star, and as a group, we can record the magnitudes on the RASC London forums. We can see like our own like curve that we can create while we're practicing our variable star observing. So stay tuned for that. So this is your task. There's the variable star plotter, and you might want to get ahead of that by going and plotting your own star charts to see if you can find our Leonis, because right after dinner, it's right overhead. Club observing weekend. We're looking at May 23rd, 24th, and thank you very much.